So guys, welcome back to the channel, and in this video we will see reflection of a light at a plane surface. So let's consider one plane surface which is a reflecting surface over here. So this is our plane surface which I have considered. Now, as mentioned in the wave theory of a light travels in the form of longitudinal waves. So let's draw a longitudinal wave over here. As we all know, in the longitudinal wave there is compression and rarefaction. So suppose here there is a compression and rarefaction. Suppose now we draw this longitudinal wave over here. What will happen is that our diagram will become too messy and we will not be able to distinguish between which is the angle of incidence and which is the angle of reflection. So just for the betterment of just for the betterment of understanding, we will draw only two rays which gives the direction of this wave. So let's see how. So I will draw this wave ray, and as let's name this ray to be A and this to be B. You need to keep in mind that A and B are moving simultaneously. So as ray A hits the ground, ray B will reach somewhere over here. So now ray A has hit the ground and ray B has reached somewhere over here, and it is still in the air and it has not hit the surface, that is the reflecting surface. So now what will happen over here is that A dash will create a wavefront, and this wavefront will be in a circular manner. If you don't know how a wavefront is created in a circular manner, then the link is given in the description box. You can view that video and this video will become much more easier for you all. So now at this point A dash will create a circular wavefront. So let's draw a circular wavefront over here. Okay, and now after creating a circular wavefront, A dash will get reflected from this reflecting surface and will reach over here. So as the A dash reaches over here, now B dash will reach the reflecting surface. Over here you need to keep one thing in mind, is that the time taken from A dash to reach the wavefront and the time taken by B dash to reach the reflecting surface is same. So after reaching the reflecting surface, B dash and A dash will both now move simultaneously from here on. Now if we join A dash and B dash, since these both rays are parallel to each other, so after joining A dash and B dash we get a 90-degree angle over here. And if we draw a tangent to this circle, as we all know that this A dash C is acting as a radius to this semicircle, therefore the tangent drawn to the radius is always at a 90-degree to it. So a tangent is always a 90-degree to a radius. This property we have done in 9th standard. And now you all must be wondering that how only this wavefront is a semicircle. Why not over here a complete circle? Because since this is a reflecting surface, so light will not pass to this reflecting surface and it will get rebounded back. And as it does not pass to a reflecting surface, therefore there will be no light over here, and thus there will be no wavefront over here. So now let's name this point to be D and this point to be E. Now what happens is that when ray A hits the reflecting surface, we draw here a normal over here. And let's name this normal to be N1, and we will draw another normal over here and we will name this normal to be N2. Now when the ray A hits the reflecting surface, Since it is incident on a reflecting surface, therefore this angle will be angle of incidence with the normal, and when it gets reflected, this angle will be equals to the angle of reflection. The same happens with the B, that is when the B hits the incident surface, this angle with the normal will be equals to the angle of incidence, and this angle will be equals to angle of reflection. So now our aim in the angle of reflection uh, and angle of incidence theorem is that we have to prove that the angle of incidence is equals to the angle of reflection. So for proving that the angle of incidence is equals to angle of reflection, first of all we must need to prove that the angle of the triangle A dash B dash D, this triangle A dash B dash D is congruent to triangle A dash C D. So this is the task in front of us to prove that the triangle A dash B dash D is congruent to triangle A dash C D. Now for proving these two triangles to be congruent, there is one common side which you will observe over here is that A dash D is common to both the triangles. Therefore A dash D is equals to A dash D, and the reason over here is the common side. Okay, now if I'll observe carefully that angle A dash B dash D is equals to 90 degree and angle A dash C D is also 90 degree. Therefore writing that angle A dash B dash D is equals to angle A dash C D, and the reason over here will be both 90 degree. And now I mentioned one thing earlier is that the time taken by A dash to travel to C is equal to the time taken by B dash to reach D. So the formula for distance is speed into time. The time taken by both of them is same, and the speed of both of them is also same, as both of them are traveling simultaneously, as they represent only a single wave. So both of them are representing a single wave, therefore their velocity will also be same, and the time taken by both of them is also same. Therefore the distance covered by both of them will also be equal. Therefore B dash D is also equals to A dash C, and thus from this we can prove that by SSA method, triangle A dash B dash D is congruent to triangle A dash C D. So now our first job is done, that we have proved that both the triangles to be equal. So now what we conclude from this congruence test is that this angle C A dash D is equals to angle B dash D A. Why? Because both of them are angles of congruent triangles. Therefore from this we have got this. So now from this we have to prove that angle of incidence is equals to angle of reflection. So now if you will observe carefully is that A dash B dash D, this is one triangle, and angle I is a corresponding angle to this triangle because it is beside the normal. Therefore what we can conclude is that angle C A dash D is equals to I, and in the same way we can say that angle B D A dash is equals to R, because after a gap of I and there is a normal, and over here we get a reflecting angle. Okay, so now from substituting the value of I and R over here, we get angle I is equals to angle R. So this was the derivation for the reflecting surface. So guys, if you have liked the video, then please do subscribe to the channel and share this video with all your friends. And in the next video we will see the refraction of a plane wavefront at a plane surface. So guys, do subscribe to the channel and share this video as much as possible. Thank you guys.